Hello friends, welcome to my channel Technical Arquen. Today we will discuss one is half adder, another is full adder. So go for it. So at first we will know what is half adder. Okay, a combinational circuit that performs the addition of two bits is called a half adder. Okay. From the definition of a half adder, we find that the half adder circuit needs two binary inputs and two binary output. Okay? The output variables produce the sum and carry bits. Okay? A and B be the two inputs and S for sum and C for carry be the two outputs. Okay, so this is the truth table for half adder. Okay, so what happened for half adder? There is a two input, one is A and that is B, and what are the combination? The combination may be 0 0 0 1 1 0 and 1 1. Okay, now if we add these two bits, means for the half adder is concerned, when two bits are add, means addition of two bits is performed, then we get two output. One is carry, it's represented by C, and another is sum, which is represented by S. So if we add this, so what happens? 0 0, the sum will be 0 and carry will be 0. For 0 1, sum will be 1 but carry also 0. For 1 0, the sum will be 1, the carry will be 0. But for 1 1, the sum will be 0 but carry 1. Okay. Now we get, this is the output for carry and this is the column for the sum. Okay. Now the sum of the product expression of two outputs, one is carry represented by C and another is sum represented by S, can be directly obtained from the truth table. So how? So suppose we are right at first C equal, so we just find out what? We are find out the product term. So that means in that particular position we find out our product term. Okay. So what will be the product term? So this is both are 1, that means we get only A dot B is a product term, that's why dot, and for 1 the variable should be normal. Okay. And now for the S, and there is only one only is present in that position, that's why you only get the one product term. Okay. Now for the this column is concerned, means find out the sum. So we are write S equal sum of the product, means there is a two product term. So first product term in that position. So what is that? A is 0, means A complement dot B. Why? B is 1, that's why it's normal. And in that position, so here A is 1, means A is normal, dot B is 0, means B is complement. So this can be written also as that. Why? Because A complement dot B plus A dot B complement is also known as XOR function, and there is a dot A dot B, this is a AND function. Okay. Now if we draw the logic diagram of the half adder from these two function, one is C equal to A dot B and another is S equal to A XOR B. So what happened? So there is a two inputs, one is A, another is B. Okay. Now at first we are find out the output for carry. So what happened? A dot B. So dot means AND operation, means should be the AND gate. Okay. And this will be your C. And for S is concerned, so what we get? XOR. So we just draw a XOR gate here. And it will be your S. Okay. So this the circuit diagram for half adder. Okay. So that means the simplified boolean function for two outputs, one is C and S, are obtained from the truth table. These are the two, and from this boolean expression we draw the logic diagram of half adder. Okay. Now we will talk on full adder. Okay. So what is full adder? A full adder forms the arithmetic sum of three input bits. Okay. Thus, it consists of three inputs and they are X, Y and Z, and two outputs and they are C for carry and S for sum. Okay. So, truth table for a full adder will be like that. So, what happened? Three inputs X, Y, Z. Okay. There is 8 combinations are there. So, if we do the 3-bit addition, now 0 plus 0 is 0 and 0 plus 0 will be 0 as sum and carry also be 0. 0 plus 0, 0. Now 0 plus 1, 1 will be the sum and 0 will be the carry. Now 0 plus 1, 1 is your output and 1 plus 0 will be 1 and 0 is also carry. 0 plus 1, 1 is the result and 1 plus 1, 0 will be your sum and 1 will be your carry. Okay. Same way 1 plus 0, 1 and 1 plus 0, 1. So that's why 1 will be sum, 0 is carry. Now 1 plus 0, 1 is the output and 1 plus 1 will be 0 is your sum and 1 will be the carry. Now 1 plus 1 is your 0, okay, and 1 is carry, and 0 plus 0 will be 0 and 1 already told as carry. So now 1 plus 1 is 0 and 1 is carry. Okay. Now 0 plus 1 will be 1 and carry is already told, that's why 1 is there. Okay. And you should remember that a combinational circuit that performs the addition of 3 bits like that truth table is known as full adder. Okay. Now we find out the sum of the products expressions for the two outputs is C and S can be obtained from the truth table. For the first column means the carry column is concerned, where the 1 is occur in that particular position we will find our product term, and for the sum column, so where the 1 is occur in that position we find out our product term. Okay. So at first we are write C equal, okay, so find out the product term. So this is the first position. So why? Because this is the 1 is occur and what the combination 0 1 1, so X is 0, so 0 means complement is a product term and both are 1, so X complement dot Y dot Z plus, because sum of the product should be the expression. Second one, this the position, so in that case X is 1, so X is normal, Y is 0, so that's why Y complement dot, and Z is also normal. Why? Because Z is 1. After this position, in that case X, Y both are 1, so that's why X dot Y and Z will be 0, so that's why Z complement. And another product is also there in that position, so here means all X, Y, Z are 1, so that's why both are all are normal, so that's why X dot Y dot Z. Okay. Now we find out S. Okay. So S, in that position we find out our product term. So what the position? X0, Y0 and Z1. X0 means X complement, Y0 means Y complement, Z1 means Z is normal. Plus, in that position X0, Y1, Z0. X0 means X complement, Y1 means Y normal, Z complement. Why? Because Z is 0. Now this position X is 1 and both are 0. X dot Y complement dot Z complement, because X is 1, Y and Z are 0. So that's why Y complement dot Z complement. Okay. And after that this position, so here all the X, Y, Z are 1. So that's why X dot Y dot Z. Okay. For sum of the product and product of the sum, I have already described in my previous videos. You can watch this and the link is given in the description box. Okay. So now we simplify these two boolean expressions. So at first we are right here C equal, what we get, X complement dot Y dot Z plus X dot Y complement dot Z plus X dot Y dot Z complement plus X dot Y dot Z. Okay. Now from these two product term we are take common Z. So what we get, X complement dot Y plus X dot Y complement. Okay. And similarly from these two product term, if we take common X dot Y, because both term contain this, so X dot Y and what the remaining part, z complement plus z. Okay, now what happened, we already know for this case x complement dot y plus x dot y complement, it is nothing but an XOR. Okay, and also for z complement plus z means it's equal to 1. Okay, so that's why we are write here z dot x XOR y. Okay, and in that case we are just write x dot y. Why? Because this part will be 1. Okay, now the simplification for the next Boolean expression. So s equal, here we got x complement dot y complement dot z, x complement dot y dot z complement plus x dot y complement dot z complement and x dot y dot z. Okay, now from this product and this product term we get common what, z. So that's why you are right here z dot, from this we only get x complement dot y complement plus, and from there we just get x dot y. Okay, so this and this product term is complete. Now for these two product term, okay, now from these two product term the common is z complement, so we just find z complement, and what the remaining, x complement dot y plus x dot y complement. Okay, the same manner we also know that x complement dot y complement plus x dot y is your x nor, right? So we can write here z dot x nor y. Okay, and here z complement, and this is already I am told that is your XOR, so we are write x XOR y. Okay, now also we know that for XOR if we just put in complement we get x nor, and also the vice versa, means if we put complement on x nor we get XOR. So we are just write this particular term in that way. So this is your complemented part, the x nor can be written in that way. Okay, so that's why I write that, and z is there. And also remember z dot something and something dot z is the similar, that's why you are just this particular term in first dot z, and this will be like the same way. Okay, suppose this is your w, so what happened, w dot z complement and w complement dot z means it's also form an XOR, so that's why you can write in that way also. Okay, means here what happened, we are just write, means we are thinking about that x XOR y as w, so in that case w dot z complement here, and here w complement dot z, so it will be what, w XOR z, and w will be this, that's why the simplify is in that way, x XOR y and XOR z. Okay, so these are the two simplified Boolean functions for full adder. One is C, other is S. So now we draw the logic diagram for full adder. Okay, so there is a three inputs x, y, z. So at first we find out our C. So first we do this XOR. So we are just draw this XOR gate. Okay, this is your XOR, and from there z dot, dot means AND, right? So there is an AND gate. Clear? Now also the another AND gate is there, x dot y. So here you are just draw x and your y. This is your also an AND gate. Now this is a plus, means we are find an OR gate. So this is your C, means carry. Clear? Now we go for S. So what happened, this is already done, what, x XOR y, this is already done, so we take from there. Okay, and another is Z. So we take Z from there, and what, also an XOR, so we just form an XOR, and this is your S. So this is the logic diagram for full adder, where we are using what, XOR and OR gate. Okay, I hope that you have understood my topic. For more videos, keep watching my channel Technical Arquin. Thank you.